Okay, how do you do this stuff on trig expressions and trig identities? I get the sense that the teacher sort of rushed through this because you did it just last week. So what's going on with the simplifying trig expressions? Well, simplifying trig expressions, they are going to ask you to take some sort of complicated looking thing here and simplify it so it's only one trig function or one number. So what you really want to do here in most of these problems, in fact, even on the trig identity side, is convert everything to sines and cosines and hope for the best. For example, this one, tangent theta over secant theta. So you convert everything to sines and cosines and hope for the best. The tangent of theta you have to know as the sine of theta over the cosine of theta, divided by the secant of theta. The secant of theta is 1 over the, I always get confused, secant would be the cosine. And you have to deal with this. Okay, so this brings up the two algebraic things that people tend to forget that you need to know how to do these problems. You need to know how to do two things, at least two things algebraically. One of them is you need to know how to deal with monsters like this, which really are 2 over 7 divided by 3 over 5. Remember how to do this? 2 over 7 divided by 3 over 5 is 2 over 7 times 5 over 3. It's sometimes called keep, change, flip. You multiply the numerator by the reciprocal of the denominator. This is one thing you're going to have to know how to do. The other thing you're going to have to know how to do, and we all hate this, is having to add fractions. You may have a problem where you're going to have to add things that don't have a common denominator, and we'll look at least one of them. But if you do that, you have to realize the common denominator is 15. You multiply this by 5, you multiply this by 3, and it's 5 plus 3 over 15, or 8 over 15. Okay, anyways, let's get back to this thing. So you're going to have to do the, this is what's called the complex fraction. You do sine of theta divided by cosine of theta times, now you flip this, cosine of theta over 1. These cross out, and it simplifies to be sine of theta. So in all these problems, you want to convert everything in sines and cosines and hope for the best. Now, when you see certain patterns like this, like sine squared theta plus cosine squared theta, you should know that that is a Pythagorean identity. So you need to know the Pythagorean identities because the chances of these coming up on these questions is about 100%. You need to know this one. Now, you either have to memorize these or derive them. But now that I look at it, there's a nice pattern to these guys. Notice that on this side, you have cotangents and tangents. So for the other ones, you always know it's going to be a 1 plus cotangent or 1 plus tangent. But what's the other one? What do you do with the other one? Notice there's a pattern here. This is a co. This is a co. You see the co's go together. See that? And the normal tangent goes with the non-co thing. See? Co-tangent. Co-secant. This is just tangent and this is secant. Okay? So that's a good way to remember these. Now, the Pythagorean identities are very useful. You can, here's one. Whoa. Here's one where pretty good chance you can, I'm not sure if you have to add fractions. I'm not sure. Cotangent divided by tangent may simplify. Something like this is reeking of a Pythagorean identity. Something like this, secant squared theta minus 1. So on your paper, you're going to have you're going to have that. You're going to see that you're going to have this on the paper. 1 plus tangent squared theta secant squared theta. See? 1 plus tangent squared theta is secant squared theta. So which means that if you subtract 1 on both sides, you see that tangent squared theta is secant squared theta minus 1. Okay? So that means that secant squared theta minus 1 is tangent squared theta. So you could replace this with tangent squared theta. See? See how it works? So you're going to need the Pythagorean identities to help you simplify things like this. So here we go again. Got it to convert everything to sines, cosines, and hope for the best. This is 1 over cosine squared theta. And this is sine squared theta over cosine squared theta. You do the complex fraction again. 1 over cosine squared x. I'm changing to x, whatever, doesn't matter. Over times cosine squared x over sine squared x. Those cancel. You get 1 over sine squared x. And we all know that sine squared x is cosecant squared x. Right? Yeah. So the answer is cosecant squared x. Okay. Now, sometimes you have to factor. If you see things like this, try difference of two perfect squares. And sometimes you're going to have to factor. This one here, I mean, clearly you're going to have to, actually, I'm not sure. Maybe you convert everything to sines and cosines and hope for the best. Okay? Okay, great. Now, so these are very much related to trig identities. In trig identities, they tell you the answer. They tell you what the thing simplifies to, and then you have to show it. So, for example, in a trig identity, they would say show. They would say show that this equals secant squared x. That's the only difference. Big thick secant squared x. So, right? That's the only difference between a simplifying trig expressions and a trig identity. They would say here show that it's equal to this. Okay, so in some ways they give you the answer, but usually the answer may not be one function. The answer may be a little more complicated, but it still uses the same ideas. In most cases, you're going to do convert to sines and cosines and hope for the best, and you're going to have to know how to deal with those fractions, and you're going to have to know how to add and subtract fractions, like 1/3 and a fifth. So let's go into a few of these. So see here, you're not simplifying. You're not making it one thing. You have to show that it's this group of things. Now, in a case like this uses an interesting pattern. Well, first of all, you can convert to sines and cosines and hope for the best on this side. But this uses something that you should be aware of. It's a cute little algebraic trick. If you see this, what is 3 plus 8 over 7? Well, that's 3 over 7 plus 8 over 7. By the way, you can work on either side, okay? Usually you work on the more complicated side, but you can work on either side. So look what you could do here. You could do 1 over cosine x plus sine of x over cosine of x. Well, look at that. Well, first of all, sine of x over cosine of x, you want to keep your eye on the answer. Well, that's tangent of x. And 1 over cosine of x is secant of x. Done. Done, done, done. So just because it's on the left doesn't mean you have to work on the left. You can work on the right. So they'll look out for that. Again, you just convert everything to sines and cosines over the best. Whatever you do, never cross multiply. Never, never cross multiply, because you are being asked to show they are equal. They are not equal yet because you are being asked to show that they're equal. So, okay. Now, again, this one also, you can just do the same game. You can just write this as cosine squared x over cosine x plus 1 over cosine x and make your life really easy. Now, here we have a cotangent plus 1. Now, that's reeking. Now, first of all, you should have the Pythagorean identities at the top of the paper. So you go to the first page and you say, well, am I lucky? Is that a Pythagorean identity? Actually, it is, and I'll do it by memory. Oh, I remember. 1 plus cotangent is equal to that cosecant thing, right? Because the co's go together. Co. Okay. Well, my God, this is easy. Oh, this is really easy. Because this thing is equal to 1 over sine squared x. Now, some teachers only want you to work on the left religiously, and you can't touch the right. Or I should say, some teachers force you to work on one side, and you've got to get it to equal the other side. Okay, that's one standard. Some teachers don't care. Some teachers say, you can work on either side, and you work on both sides at the same time and show that they're the same. So you should find out which one your teacher wants, although by now I'm not sure. Look at if he gives answers, look and see how it's done. But if you work on both sides, it's not the worst thing in the world. Now this is reeking. No, actually, here you would do convert to sines and cosines and hope for the best. On this side, probably, yeah, you would. Well, we already know what this is. This is secant squared x using a Pythagorean identity. Well, let's not go there. So you're going to want to work on this one. You convert to sines and cosines and hope for the best. So it's cosine, tangent is cosine over sine times, put an x there, cosecant is, well, cosecant, well, you got a cosecant and a secant, so who cares which one it is? It's going to be a cosine and a sine either way, right? Right? So these cosines are going to cancel, and you're going to get a 1 over sine squared x. So if you're the type of if the teacher allows you to work on both sides, then you would bring in the Pythagorean identity and write this as secant squared x, right? And then you would then notice that this is secant squared x, and you would get it right. See that? See that? Okay. If the teacher wants you to only work on one side, then you would take this 1 over sine squared x, write it as secant squared x, bring in the Pythagorean identity, and say secant squared x is 1 plus tangent squared x. And then you show the two sides are exactly the same. It's better generally to do it this way, to only work on one side, but some teachers allow you to work on both sides. So we should do one where you actually have to add and subtract the fractions. I'm not sure which one. Well, this one, maybe this one. Tangent is sine of x over cosine of x, plus secant is 1 over cosine of x. Oh, well, that's easy. I mean, there's common denominator, so you're fine there. Be nice to find one. Cosine. Okay, how about this one? So this is cosine of x. We're going to work on this side, although it's probably better to work on the other side, but let's just do it this way. By the way, there's more than one way to do these things. Cosine of x plus now secant is 1 over the cosine of x. You got a problem here because you have to add these fractions. So the common denominator is going to be cosine of x. You know what this is like doing? This is like doing 3 plus a third. 3. This is like doing 3 plus a third. So how do you do it? You need a common denominator, which is going to be cosine of x. So you already have it here. That's cool. But this one doesn't. So this one you have to multiply by cosine of x over cosine of x. So that gets you cosine of x squared plus 1 over cosine of x. Well, look at that. We're done. See that? So this requires you to know how to add fractions. The very last one, which is what's called a conjugate, is what happens when you have. Okay, let's see. What's a conjugate one? Okay, let's see. There's a conjugate one here. Oh, this one. This one's reeking of conjugate. Conjugate means that you multiply. Well, you'll see what conjugate means. If you have things like this, 1 plus sine x, 1 minus sine x, this type of thing, 1 plus sine x, and you just don't know what to do, you don't know what to do here. You don't know what to do. You're stuck. None of the methods work. So you got trouble. So this is the method you use when you see this type of thing. 1 plus sine of theta over cosine of theta. Multiply this times 1 minus sine of theta, and you'll see the magic that happens. 1 minus sine of theta. Okay, so what you get here is you multiply this together, and you FOIL this out, and it's a difference of two perfect squares, really. So it's 1 minus sine squared theta, and this is cosine theta times 1 minus sine theta. Now, that's not that bad because you're supposed to have a 1 minus sine theta in the denominator. So you're getting there. Now, we bring in the Pythagorean identity. By the way, anytime you see a 1, you are allowed to replace it with sine squared theta plus cosine squared theta equals 1, right? That's the 1. It's the 1 minus the sine squared theta over, right, in complete sentences, cosine of theta and 1 minus sine of theta. Okay, now this is working out pretty well because the sine squared theta is going to cancel, and you're going to left with cosine squared theta over cosine theta, 1 minus sine theta. Well, now you look at this thing, you want to look at the goal, look at the answer, you're getting closer, and then you realize, oh my OMG, look at this. I've got a cosine squared theta on the top and a cosine theta in the denominator, so that just simplifies to cosine theta over 1 minus sine theta. And guess what? You're done. So this is basic. So we've gone over the basic stuff. Basically, convert to sines and cosines. Hope for the best. You have to know how to do the complex fraction, which is multiply by the take the numerator, multiply by the flip of the denominator. You have to know how to add fractions. Keep in mind the conjugate, and I have a cheat sheet here which goes over all the little tools that you need to have to be ready. Sometimes you have to factor the difference of two perfect squares. That's not unusual, but it can happen. Oh yeah, yeah. If you see things like this, well, this has to do with trig equations. If you see something that you could factor through GCF factoring, go ahead and do it. You have to know how to add fractions. We talked about it. Conjugate tool we talked about. You need to have all three Pythagorean identities on your paper. You convert everything to sines and cosines. And I can't believe, oh yeah, here it is. Dealing with complex fractions. Okay, and then dealing with this little thing, right? A plus B over A is 1 plus B over A. Don't forget that. We used that before. Remember we had a 1 plus cosine of x over cosine of x is 1 over cosine of x plus 1. That can be really handy if you don't see that. It's very frustrating, but look for it. And occasionally you need to do trinomial factoring. There's virtually no chance you're going to have to do that. Here are a few worked out examples. That's it. So we did simplifying trig expressions and dealing with trig identities. And you have a slew of problems here to practice on, plus the few that your teacher gave. Okay, that's it. Bye-bye.